So here we are again with a new concept of logarithms and the properties, and today we are going to study how to sketch the graph of the logarithmic functions and describe the characteristics of logarithmic functions, like how to find the domain, range, x-intercept and y-intercept, and the end behavior of the logarithmic functions. And still, if you have not subscribed the channel, kindly subscribe, hit the button subscribe so that you will get on daily basis the notification of the new ideas of logarithms and other functions. Have a look at the graph and understand the basic concept. The first thing is that always read any of the graph from right to left. Now look at the graph and observe curve number 1. What have you observed? That the curve number 1 belongs to any exponential function and it is increasing rapidly. So we can say that the exponential functions are the functions which increases rapidly. Now on the contrary, the other curve belongs to a logarithmic function, and you can observe it is also increasing, but the movement is very slow. That means that it is increasing but slowly. And now we all know that the exponential functions and the logarithmic functions are the inverse of each other. So you can see that this mirror line or this symmetrical line can show you that they are the reflection of each other. Now the second thing is, you can see that the exponential function passes through 0 and 1, passes through the point 0 and 1. It means that the x value is 0 and the y value is 1. Whereas the logarithmic functions passes through 1 and 0. The x value is 1 and y value is 0. So you can see that the domain becomes the range and range becomes the domain of each other. So the characteristics of logarithmic and the exponential functions. So you can say that the domain of the exponential functions are all real numbers, whereas the range is starting from 0, 0 is not included, and the y values keep on increasing. But the domain of the logarithmic function is 0 and infinity, because log of 0 cannot be determined. Similarly, the log of any negative number cannot be defined. And moreover, you can say that exponential function and logarithmic function are the inverse of each other. So the domain, that means the x values of the exponential function, becomes the y value of the logarithmic functions. That means the domain changes into range of logarithm, and range of exponential function become the domain of the logarithmic function. Now y-intercept, that means the x is equals to 0 and 1. Similarly, the x-intercept of the logarithmic function, you can say that y becomes 0. So y becomes x-intercept is 1. It means that it passes through the 1 and 0 points. There is no x-intercept in terms of x for exponential functions and no y-intercept for logarithmic functions. Now, here in exponential functions, we get the horizontal asymptote, whereas in logarithmic function, we will get the vertical asymptote. Let's see how to graph it. So there is a very simple way to graph any logarithmic functions. The first thing is, try to write the domain of any logarithmic function. In order to write the domain, always write the function that is written after the log. So here the function x, that is a monomial, is written after the log. Make it always greater than 0. So to write the domain of any logarithmic function, you have to follow the rule that means greater than 0. So here 0 is not included, so you can write the domain as 0 till infinity. And range stays the same, no changes, that is all real number. Whatever the number you will write as a x value, you will either get the positive value or will get the negative value of y. Now here, since the x is greater than 0, so it will always pass through the point 1 and 0. 1 and 0 means that you have the y-intercept, the x-intercept, x equals to 1. That means on x-intercept x equals to 1, the y value is 0. As we already know that there is an asymptote in the logarithmic function, and that should be a vertical asymptote. Now what point it will lie, at the vertical asymptote will lie at what point, that you can determine from the domain, whatever the number you will get in the domain, okay, that will be the vertical asymptote. So asymptote will be, you will have vertical asymptote x equals to 0. Now after that you have to write the end behavior, which you can write with the help of the graph. But now in order to graph, always write the x and the y values and always take the easiest points, and that is already calculated, that always write 1 over b. The y value you will always get -1. What is the b? B will be the base. Similarly, you will get here 1 and 0 you will get. The third point you write here the b, and that will gives you 1. So with the help of 3 points you can just sketch the graph. So here the first point is 1 over b, whatever here it is here. The 1 and 0 you will get here, and b and 1 could be over here. So the graph will look like this one, and always extend it till here. And since you have a vertical asymptote at 0, make a dotted line on the 0. Never ever let the graph touches this horizontal asymptote, which means that the graph will come closer to the 0, but it will never ever touch the 0. So how to write the end behavior of this graph? For end behavior, you have studied in grade 9 also. We always write that when x approaches to what? First of all, always write the vertical asymptote. Here, there is no graph. So the graph is starting from the 0, and the graph will not touch the 0 also. So you can say that x approaches to 0. Y approaches to where? Where the y is going. If x is 0, where the y is going? Y values are going down and down and down. When it will stop, you don't know. So y value is going down. You know, on the top you have the positive infinity. The y values are positive. And the vertical axis at the bottom you have negative y. That means negative infinity. On the right hand side horizontal line you have the plus x, it means the positive infinity values of the x, and on the left hand side you will write minus x, that means all the values that are less than 0. So here for the first scenario x approaches to 0, y approaches to negative infinity because the graph is going down. Now next is, there are two scenarios. Now x is increasing. So x is increasing on the right hand side. Where increasing? X is positive infinity. Then the y value is where? You can see that the y value are also increasing and increasing. So you will say y approaches to positive infinity. So these are the ways you have to describe any of the graph. So let's take an example. For example, you have log base 2 of x. You have to draw this graph and draw it. The first thing is you have to write the domain. So for the domain, we always write the function that is written after the log, which is x. X should be greater than 0. So your domain will be 0 till infinity and the 0 is not included. Second point, that is range, and range is the universal for the log. Whatever you write the domain, you will get an answer. So range will always be negative infinity till positive infinity. The third thing, that is the asymptote, and I told you you have the vertical asymptote, and the vertical asymptote we always take it from the first value of our domain, that is x equals to 0. Now after that one, you will have the x-intercept. The fourth is x-intercept. X-intercept means what? Y equals to 0. So when you have the y equals to 0, x is always equals to 1. Keep it in mind that all logarithmic functions, the basic logarithmic functions, always passes through the point 1 and 0. Now the fifth thing is you have to use the end behavior. But for the end behavior, you have to wait until you sketch the graph. Now for that, you have to make a table x and y, 3 columns. Number 1 is always we write 1 over b and negative 1. Here we always write 1 and 0. And the third point is b and 1. Now what is b? B is your base. It means the 1 over base over here in the question is 2. So x equals to 0.5. Now here base in the third column, that is 2. Now if you don't agree that you will get these answers, use your calculator to verify the answers. So once it is done, draw the graph. So here you have 1, 2 and 3 in the x-axis. In the y-axis, 1, 2 and 3 in the y-axis. So the first x-axis is 0.5 and the y value is negative 1. So here 0.5 and the y value is here negative 1, negative 2. So negative 1. Here you have negative 0.5 and negative 1. The second point is 1 and 0. So you put here 1 and 0. The third point is 2 and 1. So third point is 2 and 1. But don't only draw these 3 points. Just extend your graph. How you will extend your graph? You will extend the graph, come near to the x, but never touch the x. Why? Because you have to show the vertical asymptote by making a dotted line on the y-axis. And don't stop here because it will be increased and increased and increased. Now after that, what you have to do? You have to write the end behavior. That means when x approaches to vertical asymptote, that is 0, y approaches to where? So when x is 0, the y is going down, that means negative infinity. And when x is increasing from on the right hand side, so the x values are positive infinity on the right hand side, the y value is also on the top of the x-axis. So y value is also increasing. So I hope you understood the concept when the base is bigger than 1. Now what if the base is less than 1? And one more thing, remember the base should be greater than 0. Base should never be equals to 0. So what will happen if the base is less than 1? Is a question, log of base 1 over 9 x. So you know that here the base is less than 1. So what will happen in this case? So here we have again the 3 points, that is 1 over b and negative 1. The second one always 1 and 0, and the third is b and 1. So our b is 1 over 9. So when we will write 1 over b, so b is 1 over 9. So 1 divided by 1 over 9, it will gives you 9. And the second one is 1 over 9. Now once it is done, you have to draw the graph first to determine or to describe the end behavior, because the rest of the things here, until there is no other polynomial function is written, only x is written, so all the properties will stay unchanged. So you can write domain as 0 and infinity, range all real numbers, y-intercept none, x-intercept is the point x equals to 0, asymptote always b equals to 0. And now see how to determine the end behavior. So the first point is 9 and negative 1. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 9 and negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here is negative 1. So 9 and negative 1 over here. Then 1 and 0 over here. Then 1 over 9 and 1 somewhere over here. Okay, so here is this points you can see. Now I told you to extend the graph, so we can extend. I'm showing you with another color that how I am extending this one. Now as I said that no change because of this x, so again on the x you have a vertical asymptote. Where is my pen? Let me check. So here we have a vertical asymptote, and you have to extend your graph, but do not touch the 0 value. Okay, and show your asymptote by using a colored pencil or make it dotted one. Now let's see what have you observed. The first thing is x approaches to 0, stay as it is because 0 is your vertical asymptote, and y approaches to where? When it is going 0, you can see that the y is also increasing. So you can say y is approaching to positive infinity. Now x on the left hand side there is no graph, so you have to see x approaches to positive infinity. So x approaches to positive infinity. And where have you seen the y? The y is decreasing. Why? Because y is below the x-axis. So here the decreasing, it is negative 1, negative 2, negative 3, and so on. So y approaches to negative infinity. So I hope that you would understand that how we can describe the characteristic of any graph. Now it is your turn. Pause the